When evaluating an electrical bid for a home addition, several factors must be taken into account. These factors will help determine if the bid is appropriate for the work being completed. Firstly, the scope of work is critical. This encompasses all the tasks involved in the project. In this case, the addition includes a bedroom, office, and bathroom along with a heating, ventilation, and air conditioning system. The electrical work includes installing a 100 amp subpanel, 7 can lights, 3 light fixtures, 6 receptacles in the bedroom, 4 receptacles in the office, an exhaust fan, a ground fault interrupter and lighting in the bathroom, and 2 smoke detectors in the addition. Furthermore, the existing smoke detectors need to be interconnected, and the ceiling fixtures in the existing house that were removed for the addition need to be rewired. Secondly, the materials involved significantly affect the overall cost. The type and quality of materials used will influence the price. For example, the cost of the subpanel, the light fixtures, the receptacles, the smoke detectors, and the wiring will all depend on the specific brands and models chosen. Thirdly, labor costs are a crucial component. The number of IOs required to complete the work and the experience level of the electrician will impact the labor costs. More complex installations or intricate wiring will naturally require more time and expertise. Fourthly, location plays a role. The cost of labor and materials can vary depending on the location. Prices in metropolitan areas may be higher than in rural areas due to differences in living costs and demand. Considering these factors, a cost analysis can provide a clearer picture. Based on average rates, here's a potential cost breakdown. A 100 amp subpanel might cost around $400. 7 can lights at $30 each would total $210. 3 light fixtures at $60 each would amount to $180. 6 receptacles for the bedroom at $25 each would cost $150. 4 receptacles for the office at $25 each would be $100. An exhaust fan could be approximately $150. The ground fault interrupter and lighting for the bathroom might cost around $200. 2 smoke detectors for the addition at $50 each would total $100. Interconnecting the existing smoke detectors might cost $100. Rewiring the existing ceiling fixtures, assuming there are about 10 fixtures at $25 each, would be $250. The heating, ventilation, and air conditioning air handler and outside unit installation could be around $3,000. Labor costs, estimated at $30 per hour for around 80 hours, would be $2,400. Adding up these costs gives an estimated total cost of $6,740. Therefore, a bid of $4,200 might seem reasonable. However, consider these additional points. The estimated costs of materials and labor can vary. The specific materials chosen and the prevailing labor rates can cause fluctuations. Contractors also have overhead costs, including insurance, vehicle expenses, and administrative costs, as well as their profit margin. It's important to factor these into the final price. If there's competition for the project, the contractor might be willing to negotiate a lower price. Recommendations for this situation. Firstly, if you believe your bid is competitive and covers your cost plus a reasonable profit, stand firm on your price. Be prepared to explain your cost breakdown and justify your pricing. Secondly, be prepared to negotiate with the contractor if necessary. Find out what their concerns are and see if there's any room for compromise without compromising your profitability. Thirdly, always get a written contract that clearly outlines the scope of work, the materials to be used, the payment terms, and any other relevant details. This protects both you and the contractor. Electrical codes are essential for safety and compliance. Several key requirements apply to residential electrical installations. Firstly, National Electrical Code Article 210.11 addresses branch circuits. It specifies the requirements for the number and type of branch circuits in a dwelling. For example, it mandates a minimum of 2 20-amp small appliance branch circuits for the kitchen and requires at least one 20-amp branch circuit for the bathroom. Secondly, National Electrical Code Article 210.12 discusses arc fault circuit interrupter protection. It requires arc fault circuit interrupter protection for all 120-volt single-phase, 15 and 20 amp branch circuits supplying outlets or devices installed in dwelling unit kitchens, family rooms, dining rooms, living rooms, parlors, libraries, dens, bedrooms, sunrooms, recreation rooms, closets, hallways, or similar rooms or areas. Thirdly, National Electrical Code Article 210.52 covers receptacle outlet placement. It specifies the requirements for spacing receptacles in dwelling units to ensure that no point along the wall line is more than 6 feet from a receptacle outlet. This is often referred to as the 6-foot rule. Fourthly, National Electrical Code Article 250.50 addresses grounding electrode systems. It requires all grounding electrodes that are present at each building or structure to be bonded together to form a grounding electrode system. This ensures a low impedance path to ground for fault currents. Fifthly, National Electrical Code Article 314.16 concerns box fill calculations. It provides the rules for calculating the maximum number of conductors permitted in a box based on the box size and conductor sizes. This prevents overcrowding of conductors, which can lead to overheating and fire hazards. Sixthly, National Electrical Code Article 334 covers non-metallic sheath cable, also known as ROMEX. It specifies the permitted uses and restrictions for non-metallic sheath cable, including requirements for support, protection, and installation methods. Seventhly, National Electrical Code Article 404.2 addresses switch requirements. It requires that switches be installed to control lighting outlets and appliances, and it specifies the mounting heights and other installation requirements. Eighthly, National Electrical Code Article 406.4 discusses receptacle requirements. It covers the installation requirements for receptacles, including grounding requirements, tamper-resistant receptacle requirements in dwelling units, and ground fault circuit interrupter protection requirements in certain locations. Ninthly, National Electrical Code Article 410 covers lighting fixtures, lamp holders, and lamps. It specifies the requirements for the installation of lighting fixtures, including support requirements, clearance requirements, and wiring requirements. Tenthly, National Electrical Code Article 760 addresses fire alarm systems. It covers the installation requirements for fire alarm systems, including wiring methods, power supply requirements, and device placement requirements. These are just some of the key National Electrical Code requirements that apply to residential electrical installations. It's important to consult the latest edition of the National Electrical Code and any applicable local codes to ensure compliance with all requirements. Additional considerations include ensuring that all wiring is properly sized for the intended load, using appropriate overcurrent protection devices such as circuit breakers or fuses, and properly grounding all electrical equipment to minimize the risk of electric shock. Also, it's important to conduct thorough testing and inspection of the electrical installation to verify that it meets all applicable codes and standards and that it is safe and functional. Remember that electricity can be dangerous, and it's always best to consult with a qualified electrician for any electrical work to ensure that it is done safely and correctly. When estimating electrical work, consider several factors to arrive at an accurate bid. Firstly, calculate the material costs. Create a detailed list of all materials needed, including wire, conduit, boxes, fittings, devices, and lighting fixtures. Obtain current pricing from suppliers. Secondly, estimate the labor hours. Determine the number of hours required to complete each task, such as wiring, device installation, and fixture mounting. Consider the complexity of the job, accessibility, and any potential challenges. Thirdly, account for overhead costs. Overhead includes expenses such as insurance, vehicle costs, office supplies, and administrative expenses. Calculate a percentage of the total job cost to cover these expenses. Fourthly, include a profit margin. Profit is the amount of money you want to earn on the job. It should be a percentage of the total job cost, including materials, labor, and overhead. Fifthly, factor in permit fees. Electrical permits are typically required for new installations or modifications to existing electrical systems. Obtain the permit fees from the local building department. Sixthly, consider travel time and expenses. If the job requires significant travel time or expenses, factor these into the bid. Seventhly, account for any special equipment or tools. If special equipment or tools are needed for the job, such as a trenching machine or a lift, include the rental or purchase cost in the bid. Eighthly, be prepared for contingencies. Unexpected issues can arise during electrical work, such as damaged wiring or unforeseen obstacles. Include a contingency allowance in the bid to cover these potential problems. Ninthly, clearly define the scope of work. The bid should clearly define the scope of work, including what is included and what is excluded. This can help avoid misunderstandings with the customer. Tenthly, provide a detailed breakdown of costs. A detailed breakdown of costs can help the customer understand the bid and justify the price. It also demonstrates your professionalism and attention to detail. By carefully considering these factors, you can develop an accurate and competitive electrical bid that covers your costs, overhead, and profit, while also providing value to the customer. Remember to stay updated on current pricing, codes, and regulations to ensure your bids are accurate and compliant. When installing a sub-panel, there are several important steps to follow. Firstly, safety is paramount. Always turn off the main power before starting any electrical work. Use appropriate personal protective equipment, such as safety glasses and gloves. Secondly, select the location of the sub-panel. Choose a location that is easily accessible, dry, and has sufficient space for the sub-panel and wiring. Thirdly, mount the sub-panel. Securely mount the sub-panel to a wall or other support structure using appropriate hardware. Ensure that the sub-panel is level and plumb. Fourthly, install the feeder wires. Run the feeder wires from the main panel to the sub-panel. The feeder wires must be sized appropriately for the amperage rating of the sub-panel. Use the correct type of wire and conduit for the installation. Fifthly, connect the grounding wire. Connect the grounding wire from the main panel to the grounding busbar in the sub-panel. This provides a path for fault current to flow back to the source, helping to protect against electric shock. Sixthly, install the branch circuit breakers. Install the branch circuit breakers in the sub-panel to protect the individual circuits. The size of the circuit breakers must be appropriate for the ampacity of the branch circuit wiring. Seventhly, connect the branch circuit wires. Connect the branch circuit wires to the circuit breakers. Ensure that all connections are tight and secure. Eighthly, label the circuit breakers. Label each circuit breaker with the corresponding circuit it protects. This makes it easier to identify and troubleshoot circuits in the future. Ninthly, inspect the wiring. Inspect all wiring to ensure that it is properly installed and connected. Look for any loose connections, damaged wiring, or other potential problems. Tenthly, test the sub-panel. Test the sub-panel to ensure that it is working properly. Use a multimeter to check the voltage and current on each circuit. Verify that the circuit breakers are tripping properly. Additionally, make sure that all connections are tight and secure and that the sub-panel is properly grounded. After testing, turn on the main power and verify that all circuits are working as expected. If any problems are found, troubleshoot and correct them before putting the sub-panel into service. Remember to follow all applicable electrical codes and regulations when installing a sub-panel. If you are not comfortable performing electrical work, it's best to hire a qualified electrician to do the job. When installing receptacles, follow these steps. Firstly, turn off the power. Always turn off the power to the circuit you are working on before starting any electrical work. Use a voltage tester to verify that the power is off. Secondly, remove the old receptacle. Remove the cover plate and unscrew the old receptacle from the electrical box. Disconnect the wires from the old receptacle. Thirdly, prepare the wires. Strip the insulation from the ends of the wires, exposing about 1/2 inch of bare wire. Fourthly, connect the wires to the new receptacle. Connect the wires to the new receptacle according to the wiring diagram. Typically, the black wire goes to the brass screw, the white wire goes to the silver screw, and the grounding wire goes to the green screw. Fifthly, secure the receptacle to the electrical box. Screw the new receptacle into the electrical box. Ensure that the receptacle is level and flush with the wall. Sixthly, install the cover plate. Install the cover plate over the receptacle. Seventhly, turn on the power. Turn on the power to the circuit and test the receptacle with a receptacle tester to verify that it is working properly. There are several types of receptacles. Standard receptacles are the most common type of receptacle. They have 2 slots for the hot and neutral wires and a hole for the grounding wire. Ground fault circuit interrupter receptacles are designed to protect against electric shock. They have a built-in sensor that detects ground faults and tricks the receptacle, cutting off the power. Tamper-resistant receptacles have a built-in shutter mechanism that prevents children from inserting objects into the slots. They are required in new construction in many areas. Underwriters Laboratories listed receptacles are tested and certified by Underwriters Laboratories to meet safety standards. Arc fault circuit interrupter receptacles are designed to protect against electrical fires. They have a built-in sensor that detects arc faults and trips the receptacle, cutting off the power. When installing lighting fixtures, consider these points. Firstly, determine the type of lighting fixture you need. There are many different types of lighting fixtures available, including incandescent, fluorescent, light-emitting diode, and halogen. Choose a fixture that is appropriate for the location and application. Secondly, select the appropriate size and wattage. The size and wattage of the lighting fixture should be appropriate for the size of the room and the amount of light you need. Thirdly, install the mounting hardware. Install the mounting hardware for the lighting fixture according to the manufacturer's instructions. Ensure that the mounting hardware is securely attached to the ceiling or wall. Fourthly, connect the wiring. Connect the wiring to the lighting fixture according to the wiring diagram. Typically, the black wire goes to the hot wire, the white wire goes to the neutral wire, and the grounding wire goes to the grounding screw or wire. Fifthly, install the light bulb or lamp. Install the light bulb or lamp in the lighting fixture. Sixthly, install the cover or diffuser. Install the cover or diffuser over the lighting fixture. Seventhly, test the lighting fixture. Turn on the power to the circuit and test the lighting fixture to verify that it is working properly. When installing smoke detectors, keep these tips in mind. Firstly, install smoke detectors on every level of the home. Install smoke detectors on every level of the home, including the basement. Secondly, install smoke detectors inside and outside of sleeping areas. Install smoke detectors inside and outside of sleeping areas to provide early warning of a fire. Thirdly, follow the manufacturer's instructions. Follow the manufacturer's instructions for installing the smoke detectors. Fourthly, test the smoke detectors regularly. Test the smoke detectors regularly to ensure that they are working properly. Fifthly, replace the batteries regularly. Replace the batteries in the smoke detectors regularly to ensure that they have a reliable power source. Interconnecting smoke detectors means that when one smoke detector detects smoke, all of the smoke detectors in the home will sound an alarm. This provides early warning of a fire, even if the fire starts in a remote area of the home. There are 2 ways to interconnect smoke detectors: wired interconnection and wireless interconnection. Wired interconnection involves running wires between the smoke detectors. This is typically done during new construction or remodeling. Wireless interconnection involves using radio frequency signals to communicate between the smoke detectors. This is typically used in existing homes where it is difficult to run wires. In Maryland, there are specific requirements for smoke detector installation. Maryland requires that all new homes be equipped with interconnected smoke detectors. Maryland also requires that all existing homes be equipped with smoke detectors that meet certain standards. Local codes and regulations can vary, so it's essential to check with the local building department for specific requirements in your area. Furthermore, it's crucial to use appropriate wiring methods and materials. Use the correct type and size of wire for the electrical circuits. Follow all applicable electrical codes and regulations when installing wiring. Use appropriate conduit or cable protection where necessary. All electrical work should be performed by a qualified electrician. Electricity can be dangerous, and it's always best to consult with a qualified electrician for any electrical work to ensure that it is done safely and correctly.